All right, guys, let us consider our exam question, which is for our advanced level mathematics. In this case, that is our paper one, which we wrote in June 2024. So just gonna consider the first part of our questions. Remember, this question paper is supposed to be having 120 marks. It consists of 120 marks, and you are required your answers to be given to two significant figures if they are not exact, and for angles to the nearest degree. So we're just going to consider that and make sure that you do answer all questions. But in this case, like I said, we're going to consider the first part of our revisions. That is to see how these typical questions were supposed to be attempted. How are you supposed to attempt these typical questions? And for the future reference or future revisions, let us make sure that we do send clear questions. At least if I have got something like this, guys, I'm not going to have a problem to revise anything with you if we have got something that is clear like this. So let's make sure that we do send clear question papers that we can revise together like this one. This is a clear question paper. I can work with you. Not something that is not clear, guys. It's gonna be your delay to your side. So make sure that when you're taking these photos, make sure that concentrate. Take something that is clear. We work on it. Do not rush when you are doing that so that we can have our revisions on a clear platform. So you can send those questions +27 618 866 864. That is 4043. Okay, let's just hope it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so it's fine. 061864 4043. So you just send your questions on this number. Clear question papers, like I said. All right, so paper 2, we are just waiting for you guys. If you have it, you send them. Make sure that it is clear, like I said. All right, we were given the first part of our question. A sequence is defined by, so we have got this sequence that is defined by un plus 1, which is equal to, that is 3 un plus 1. So just try and analyze what this statement means. If this is n, this is n plus 1, meaning to say if there is a 1 here, it's going to be 1 plus 1, which is a 2. Okay? So meaning to say if you're finding u2, this is supposed to be u1. If this is 2, it means that will be 2 plus 1, meaning to say you're finding u3. If this is 3, you add a 1 here, 3 plus 1, that is you're finding u4. So that is the typical way of finding or determining for this typical sequence of this nature. So we are given here, write down the first 4 terms of the sequence, given that u1 is equal to 0. So you just play around, same way that I was saying. If this is 1, then that will be 1 plus 1, which is 2. So you're going to find u2. Okay, so originally you are given u1 to be equal to 0. So what is going to be the value of u2? So as we saw that if this is u2, this will be u1. So we've got something like this, 3 u1 plus 1. But our u1 is equal to what? As 0. So you substitute that. That is going to be 3 times 0 plus 1, which is a 1. So it is the same thing even for our u3. It means if this is 3, there is going to be 1. 3 minus 1, which is a 2. Just like this is 1, this is 2, 2, this is 3. So this is plus 1, meaning to say on this side, you subtract. So if this is 4, you subtract 1 this side, it will be 3. If this is 5, you subtract 1, this will be 4. If this is 6, and so on and so on. So u3, it means this side is going to be having a 2. So it's going to be 3 u2 plus 1. Plus 1 is still there. But remember, we got this u2. We have it. u2 is equal to what? We have got its numerical value. That is a 1. So you substitute a 1. 3 times 1, which is 3 plus 1. That will be a 4. So the same thing, even to find our u4, it means that will be, if this is 4, this will be a 3. So that is 3 u3 plus 1, which will be equal to what? If we substitute, because we calculated this u3 here, we have its numerical value, which is 4. Substitute that 4 here. 3 times 4, 12 plus 1, which is 13. All right, so we've got 1, 2, 3, 4 terms, which are the first 4 terms of our sequence. So that is the relationship that you are given. And item 2, hence describe. So from this part, you're supposed to describe how these numbers are related. So that is to describe the behavior of the sequence. So as you can see, these values are increasing, 0, 1, 4. They are increasing. So it's going to be having bigger values. As we know that having bigger values, that means it is diverging. So the sequence diverges, okay, or is diverging. That is getting big to the negative or to the positive. So this one is getting big values to the positive, okay? Item 3, express U3 in terms of U1. We are not supposed to have U3 as a numerical value. No, we are supposed to write U3 in terms of U1, just like what we are seeing here on U2. It's written in terms of U1, 3, U1 plus 1. So you're supposed to write U3 in terms of U1. How is this possible? Okay, let us consider this. We do understand that from this simplification, this is what we had on U3. U3 is written in terms of what? Originally, from what we can see, it is written in terms of U2. This is the statement. Remember, if this is n plus 1, this will be n. So if this is 2, this will be 2 plus 1, which is 3. So this is U3 in terms of meaning to say what you are writing here, what you are seeing, we are seeing U2. So this is in terms of U2. So how can we write it in terms of U1? We simply go back and substitute what we are given that is representing the part that we do not want. We do not need this, the U2, this part here. So you're supposed to remove this part of U2 by the equivalent expression for that U2, okay? Which is this one. So you're talking about this expression of U2 because U2 is in terms of U1. So let's substitute. So it means our U3 is going to be 3 times. In place of the U2, you substitute what is equivalent to the U2, which is 3 U1 plus 1. This is what we have here in place of U1. This is our U2. In place of our U2, this whole part, 3 U1 plus 1. You substituted in place of what? In place of U2. But do not forget that here we are supposed to have a plus 1. So we're going to add the 1 at the end. So that gives us U3. So let's expand. This will be 3 times 3, which is 9 U1 plus 3 times 1, which is 3 plus a 1. So it means our U3 can be given as 9 U1 plus a 4 if we add these two. So this means that if we are to substitute back, because we are given this value of U1, remember you're given that U1 is equal to what? Is equal to 0. So you can prove that if you substitute this U1, which is a 0 like this one, you must obtain the same value that you had on U3, the same answer that you obtained before. U3, we substitute this not because we had a U1, but because we had a U2, and we substitute and got a 4. So now we have it in terms of U1, and we have got the value of U1. So if we substitute that U1 here, which is a 0, we must obtain the same answer, which is 4. Is that so? 9 times 0 plus 4, that's a 4. So meaning to say this statement is correct. If you substitute the value now of U1 and you're obtaining something else, ask yourself, why is that so? Because it's supposed to give us the same U1. So that is another way that you can actually test your work in exam, just to see if you are in the right direction. Then on question number 2, we are given the variables x and y. I had actually a class on this one, a separate class. Make sure that you go through on the relationship that we have on these variables that will give us linear equations. But in this case, you were not plotting anything. Let's see. They are saying the variables x and y are related by this equation where a and b are constants. When the values of ln y are plotted against the values of x, okay, a straight line is obtained, as we know, passing through these points. Calculate the values of a and b in exact form. Whatever that you're supposed to do is supposed to be in exact form. Okay, there are two things to consider here. We have got the variables x and y that are related. The variables x, y related by this equation, y is equal to a e to the exponent of bx. And as they are related, a graph is drawn, which is a straight line graph. As we know, we are supposed to have a straight line graph, which is of the values of the ln of y and the values of x. So we do understand when we are given a statement like that, if a graph is drawn using the values of x and the ln of y, like this, a straight line, definitely we are going to have our straight line passing through the x-axis and also the y-axis, which is from the Cartesian plane. But the fact is that we are working with the ln of y. What happened for us to have the ln of y? It means on this equation, we had to introduce, in place of y, we had to introduce a ln. For us to obtain the graph having a ln, we introduced a ln. Remember, you're supposed to have our equation of y is equal to mx plus c in this format. So they introduced a ln to obtain this format. That is why we're having a ln there. So we have a ln, introduce that. So we're going to introduce a ln both sides. We introduce a ln both sides. But the fact that you have introduced a ln, you are going to apply the concept now of our logarithms. Remember, these are logarithms. What happened before? What happened before? What made us to multiply a and b together? It was because these logarithms were being added together, the log of a and the log of b. They were added together. So meaning to say, you're talking about the ln affecting a and also affecting e to the exponent of bx under addition. It's a product. If it was a division, you subtract. What happened before? For us to obtain ln a over b, it was because we are subtracting the ln of a minus the ln of b. Log of a minus the log. Same concept of our log. So now that we have got this, let's figure out how can we obtain something of this nature written in terms of the ln of y. All right. So the ln of y is equal to where we've got our x is this part, and it's carrying a ln. As we do understand under our logarithms, an exponent, we are going to drop that exponent. So it is going to be bx. It was supposed to be like this, bx, the ln of e. And we do understand that the ln of e is equal to 1. So that means it's just bx times 1, which is bx plus the ln of a. So the order there, I'm trying to have the part of y and the part of x, the constant. Remember, a is a constant. We do not have x here. So this is same as c, a constant. So that is why I'm writing it in this format. So having it in this format, guys, we can conclude we have a linear equation, even though it's written in terms of a ln. So bringing this into this format here that we are given here, bringing it to this format, we can see that y is representing the ln of y. That is what we can conclude. Y is representing the ln of y. This m, which is the gradient, is representing this part. Remember, it's mx. So this is the b that we are having, which is representing what? The gradient. Remember, this is from gradient. Then the ln of c, the ln of a, this one, sorry, is representing the c. So c is representing the ln of a, where we know that c is the y-intercept. So by knowing or by understanding this, we do understand that we have got the y-intercept there. We have got the y-intercept. And if you take closely on these points, because we are given to calculate the value of a and b, if this line passes through 0 ln 2, when x is 0, what does it mean? When x is equal to 0, this is the y-intercept. So they are giving us a y-intercept. They're not stating that this is the y-intercept. No, you're supposed to know that the x is equal to 0. If y is, maybe there was a 0. Let's say we had a 0 here. It means this is the x-intercept. But we do not have a 0. It's 3 ln 5. But this 0 ln 2 is the y-intercept. So we have got the 2 points there. 0 ln 2, which is the y-intercept. There's no way x can be 0 and this point is not the y-intercept, all right? And another point, it is given as 3 ln 5. Maybe it is just somewhere here, 3 ln 5. It's not the y-intercept. It's not the x-intercept. It's just a normal point. But because this one, it's a special point that we can take into consideration, we are going to use this ln of 2, the y-intercept value. The y-intercept is the ln of 2. Remember, x is equal to 0. And we said the y-intercept is represented by what? The ln of a. From our graph, it's c. But from this graph, it's what? Ln of a. So if ln of a is the y-intercept, it follows that ln of a is equal to the y-intercept on our graph, which is the ln of 2. It's an equation that you have formed. Guys, there's no way that ln of a will be equal to ln of 2 and a is not equal. Definitely a is equal to 2. There's no way. The ln and the ln are the same. Remember, ln is just log of base e. So it means we have got the value of a from this. You are not drawing any table. Remember, if you were to draw a table, it was going to be the values of x versus the ln of y. Then you've got a table there. No, you're not having that. The table is not needed. It's not about the table, this question. All right. So there we've got the value of a. What about the value of b? B is the part of the gradient, which is this part here, which is representing, remember, m represents the gradient. M represents the gradient. So it's either you are going to calculate that gradient because you have got the points. Okay, this is what I'm trying to say here. It's either you are going to calculate the gradient because you have got the points. Remember, M represents the gradient, guys. So B will be the gradient, as we said before. This will be the gradient. So you just calculate the gradient because we've got the 2 points here. Just calculate the gradient. Remember the gradient change in y over the change in x. x1, y1, then x2, y2. So you're going to have the change in y over the change in x. So that's y2, which is the ln of 5 minus the ln of 2, which is the y value, over the x. We've got 3, x2 minus x1, which is 3. So that's it. So in exactive form, you are not going to use a calculator. You have to simplify this. Subtraction, we talked about this. When you're subtracting, you're going to divide the number. So it's ln of 5 over 2, everything over 3 minus which is 3. So that's it, guys. This is same as 1 over 3. 1 over 3, the ln of 5 over 2. So this is the value of what? Of b. Just like that. In exact form. The gradient concept. The ln of a from the y-intercept. We have got the y-intercept there. So that was an advantage of the question. All right, let's consider another part of our question. Express on number 3, we asked to express this in partial fractions. 7 marks for that. Okay, let's see our partial fraction our fraction that we are supposed to express into partial fractions. Remember, this was given as 2x. So we've got something like this, 2x minus 3. All right, let me just try and see. Over x squared into x squared minus 4. So this is over x squared into x squared minus 4 like this. So yes, you can consider this as a quadratic, it's fine. Or you can consider it as a repeated linear. Just check on partial fractions. Also for the N5 mathematics, talked about the partial fractions, but I'm gonna also talk about this separately for A level. Just time, guys. We just need time for that. We can consider this as a quadratic. It's up to you, where we have got the concept of ax plus b over x squared. Then you separate it later on. Or you can consider this as a repeated linear. Remember, a repeated linear, if you are given x with exponent of 3, this part will increase up to the exponent of 3, a over x plus b over x squared plus c over x to the exponent of 3, like that, increasing up to the term that you're given. So it's the same thing that we can do. But what about this bracket? It's not a quadratic because we can factorize this. It's a linear. There's a difference of 2 squares. X squared minus 4. Remember, that's a difference of 2 squares. So meaning to say this was supposed to be written as 2x minus 3 over x squared into x minus 2 into x plus 2 from our difference of 2 squares. The square root of this, the square root of this. So like I said, I'm going to treat this as a repeated linear. It's a linear expression that is repeating itself. So that is a over x plus you increase from that x. So it's going to be b over x squared up to that term. So if it was even a bracket, x plus 3 to the exponent of 3, you start with a over this, x to the exponent, x plus 3 and so on. A over x plus 3 plus b over x plus 3 squared plus c over x plus 3 to the exponent of 3, like that, up to the last exponent that you're given there. So that is it. Then we move on to the linear. This is just a straight linear, c over x minus 2, another straight linear, d over x plus 2. So you've got 4 constants to be calculated here. So let's find out what's going to happen. So we're going to relate our numerator, 2x minus 3 is equal to, all right, so let's just even write like that, is equal to, let's start with this part of a. So that will be a into what? So the x divides with the x squared, that will be x. Then we remain with these 2 brackets of x minus 2 and x plus 2. Plus, we take our b, we divide the x squared and x squared. As you can see, these will cancel. You remain with these 2 brackets. So you remain with x minus 2, x plus 2. You do the same thing on the part of c, the x minus 2 cancels, meaning to say you remain with x squared and x plus 2. So that's c into x squared into x plus 2. Okay. Then we move on to d. The x plus 2 and x plus 2 will cancel. You remain with the first 2 parts that you're given there. So that means we're going to have plus d times x squared into, remember the x plus 2 and x plus 2 canceled. So you have x minus 2. So this is something that you're going to have, something of this nature. So you can see, guys, we've got a lot of things there, but do not worry because these are just linear part. So you can consider the x is on its own. So x can be equal to 0. When x is equal to 0, you can eliminate every part where x is outside of the bracket, like this. X is outside of the bracket, x is outside of the bracket, x is out of the bracket, like it's not like x minus 2. So all these are zeros. So you're going to remain with the part of b. All right, so if x is equal to 0, what are you going to have this side? That will be minus 3 is equal to, you substitute a 0 here on b. That's 0 minus 2, 0 plus 2. That will be minus 2 times 2, which is a minus 4. So there we are going to obtain minus 4b. Divide by minus 4. And minus 4, you've got the value of b, which is 3 over 4. So that's it. Then we look for another linear bracket. Just equate it to 0. You can take x minus 2. So giving x minus 2, equate this to 0. It means x must be equal to what? To 2. So when x is equal to 2, we are going to substitute 2 here. 2 times 2, 4 minus 3, which is 1, is equal to. So it means every bracket where we are having x minus 2, where we took this x minus 2, it's going to be a 0. There is x minus 2 here. There is x minus 2 here. It's going to be a 0. There is also x minus 2 here. So meaning we're going to remain with this part. Okay. So that means we're going to substitute 2 on this part. That's 2 squared times 2 plus 2. All right. That's simply 4 times 4, which is 16. So we've got 16c there. So c will be 1 over 16 if you divide. All right. So that's it, guys. let's consider another part. Okay, just a little bit here. So we're going to consider another part. Let's just say the bracket of x plus 2 this time. All right, so we're going to consider the bracket of x plus 2. All right, so considering the bracket of x plus 2, if x plus 2 is equal to 0, it means x must be equal to minus 2. So when x is equal to minus 2, we are going to affect here minus 2. That will be minus 4 minus 3, which is minus 7, is equal to, wherever there is a bracket of x plus 2, where we took this x plus 2, we are going to have a 0 there, because x plus 2 is equal to what? To 0. So that's a 0 there. That's a 0 again. That's a 0 again. So meaning to say, we are going to focus on this part of D, because we do not have x plus 2 there. So in place of x, that will be 2 squared times minus 2 minus 2. Remember, our x is minus 2. So that's minus 4 times 4, which will be negative 16. So that's negative 16D. Divided by negative 16, that was going to give us the value of D, which is 7 over 16. So as you can see, we are now stuck. We do not have any other bracket to equate to 0. We do not have any other bracket that we can take and say this must be equal to 0. So it's either you are going to expand everything, then you relate the part of the coefficients. It's up to you. Or you can simply say, check that I have B, C, and D. Of all the constants, it's only A which is remaining. So when it's like that, you can just choose any number of your choice. Choose any number of your choice that you do not have here. We can't substitute 2 because you have C again. You can't substitute when x is minus 2 because you obtain the value of D that you obtained before. You can't substitute as 0 because you have the same x, the same value of B that you calculated. So out of these values, which were direct from the brackets and the x concept, choose any other of your choice. So you can just choose a simpler value when x is equal to 1. Guys, when x is equal to 1, by sight, you can just substitute everywhere. So when x is 1, you substitute 1 here. That's 2 minus 3, which is minus 1, is equal to. So there we're going to substitute a 1. Wherever there is x, we substitute a 1. So that's 1 minus 1, 3. So it's going to be minus 3 and so on. But you're going to multiply to a. So that will be minus 3a. You do the same thing, substitute 1 in place of x, substitute a 1. That means we are going to obtain minus 3 in that case, all right? So if you substitute a 1 here, it's going to be a minus 3. So that's minus 3 times b. Remember, we have the value of b, so you're going to multiply to the value of b. Guys, where is my a here? This is minus 3a, all right? Our b, that is 3 over 4. You do the same thing on the part of C, substitute a 1. We are going to obtain a 3 there, positive 3. Okay, then you substitute the value of C because we have it. C is 1 over 16 plus, we do the same thing. We substitute a 1 in place of x here. On the part of D, we are going to obtain a minus 1. So that will be a minus 1. So that will be a minus 1 times the value of D that you calculated, which is 7 over 16. That is the value that you obtained of what? Of D. So that's it. So remember, these are the values that you obtained before, the B, the C, and the D. We have these values, so you can substitute them, okay? So let's simplify. So this is you guys and your calculator. This is you guys in the calculator. Make sure that you get rid of your calculator. Use your calculator properly. You are going to obtain minus 5 over 2. Then you can transpose the minus 5 over 2 this side. That will be a plus. So it will be minus 1 plus 5 over 2, which will give us a positive 3 over 2 equal to minus 3a. So to find the value of a, guys, we can simply divide by negative 3 by negative 3. That is obtaining the value of a. So a is going to be negative 1 over 2. This and this can cancel. That will be negative 1 over 2. Remember, we have got a negative there. So that is our A. In that case, we have our B, we have our C, we have got our D. So this is it. You're going to substitute. So guys, I'm just going to erase here because we saw how to calculate this, no problem. So after obtaining these values, the major part now is that you're supposed to substitute the values that you obtained. All right, you must substitute the values that you obtained into this equation. Remember, we obtained also our A minus 1 over 2. So you're going to substitute in place of A, that is minus 1 over 2. So instead of me writing minus 1 over 2 over x like this, I can write this as minus 1 over the 2 multiplies x. So it's going to be minus 1 over 2x. Okay? The same thing on the part of B. Instead of us having, I'm not saying it's wrong, 3 over 4 like this over x squared, we can take this 4 into the denominator. So it's going to be 3 over 4x squared. The C, we have got 1 over 16. So the same thing, 1 over 16 over x minus 2. The same part with our D, 7 over 16. So that will be 7 over 16 into x plus 2 like this. All right. So you can have your final answer this way. So that is our partial fractions, guys. And as we know, we can have a part where we will be able to integrate whatever that you have obtained. So make sure that you revise your integration also in your revisions. Check your integrations. That can be very, very useful. All right, on number 4, you are given 7 marks again to solve this equation, giving the answer in exact form again. So this question, but they wanted you to work with exact form, guys. Okay, anyways, let's see. So that is question number 4, where we are given e to the exponent of 2x plus e to the exponent of minus x over 5. This is equal to 1. These are just exponential equations that you're given from our normal quadratic equation, but being disguised in a way that you might not even see. That is a quadratic equation. How? All right, this is same as over 1, just cross multiply. E to the exponent of 2x plus e to the exponent of minus 2x is going to multiply this and this. So 5 times 1 is 5. There is a negative exponent, same as this part, but this is a negative. So get rid of that. Remember your laws of exponent. This is same as 1 over. So it's e to the exponent of 2x plus 1 over e to the exponent of 2x is equal to 5, which we can see that it's exactly the same as this one. So it's just like you're given an equation x plus 1 over x is equal to 5. How can we solve this? Get rid of the x in the denominator. You multiply each and every part by what? By x. So it's the same thing that you are given, because this is the same as over 1. This is the same as over 1. So the LCD of these denominators, the lowest common denominator is e to the exponent of x, which is our LCM. So with that, we are going to multiply each and every term by that LCD, which is our LCM, by e to the exponent of 2x, e to the exponent of 2x, e to the exponent of 2x. So what is going to happen here? We are multiplying the same term. X times x is x squared. So this is same as e to the exponent of 2x squared. Just like x times x is x squared. All right. This will cancel. The e to the exponent of 2x and e to the exponent of 2x will remain with plus 1, which is equal to these two just multiply 5e to the exponent of 2x. So like I said, these are just disguised quadratic equations. Disguised. As you can see, this is a quadratic. The highest exponent, there is 2. It's just like you're given x squared plus 1 is equal to 5x. You take this to the other side, you formulate your normal quadratic equation. Ax squared plus bx plus c is equal to 0. We know the format. So you're supposed to take this to the left-hand side so that will be a negative there. So it's e to the exponent of 2x raised to the exponent of 2 minus, becomes a minus because it crossed the equal sign, e to the exponent of 2x plus a 1 is equal to 0. We have exactly the format of a quadratic equation, this format. But if you are having challenges now working with the e that we are seeing there, guys, introduce a constant of your choice in place of the, because it's the same thing. So you can even let this e to the exponent of 2x to be equal to a certain constant of your choice. You can introduce y there. You can introduce k there. So you can just let k be equal to e to the exponent of 2x. So if k is e to the exponent of 2x, it means in place of this e, I'm going to have k squared. All right. So let us just have this equation this way. So it's going to be k squared minus 5. In place of this, we substitute with k. So that is minus 5k plus 1 is equal to 0. We have that quadratic that we are used. We're not to say this was not a quadratic. Guys, we could have solved with that. If you understand this, what is the quadratic equation? Remember, x is equal to minus b plus or minus the square root of b squared minus 4ac, everything over 2a. There is no need for me to have this. I can even have it from this because I can see this is the same as our x squared. This is the same as our x. So I can even take it that way. So it will be, instead of us having this as x, it will be e to the exponent of 2x is equal to. So you're solving for e to the exponent of 2x. But in most cases, you guys, you tend to have a challenge now. You use a wrong interpretation there, which makes it to be wrong. So that is why I just let you guys introduce your constant. I mean, the other letter that represents in place of that given e to the exponent of 2x. Just have something that is easier to work with. A letter, just have a normal letter that you can use. A normal letter that you can use into consideration. All right. So since this is for k, it means also this will be k is equal to. So therefore, let us solve. As we can see, there is a 1 here, which is our a, coefficient of k, which is our b, and our c. So that is a, b, c. So let us substitute. So k is equal to minus b, which is minus 5 plus or minus the square root of b squared. That's minus 5 squared minus 4 times a, which is 1 times c, which is 1, everything over 2 times a, which is 2 times 1. So that is it, guys. We're going to have this. Remember, we need in exact form. That's why we have to keep our said form in the simplification. We must keep our said form. A minus, that's a plus. Plus or minus the square root of, simplify this on your calculator. That will be 21, everything over 2. So that's it, guys. This is our k. So k can be given as 5 plus the square root of 21 over 2. Or we can have our k as 5 minus the square root of 21 over 2. We were not given this. No. Our equation is of x. It is carrying x. K is something that you introduced, so you must refer back to the introduction. K is equal to what? This is not part of our equation. We introduced this, but remember what we had before, that k is equal to e to the exponent of 2x. So in place of k, we can write this as e to the exponent of 2x is equal to 5 plus the square root of 21 over 2, or e to the exponent of 2x is equal to 5 minus the square root of 21, everything over 2. Guys, we need to solve for x. We are back to the equation where we have got x, but it's still having the exponents there. Just bring this back to your normal equations. E to the exponent of x is equal to 2. You are introducing the ln both sides. X ln e is equal to ln 2. Then ln 1 is 1. So x is equal to ln 2. Just like that. So even if we have these square roots of this, we're going to introduce the ln both sides. So remember the ln here also, the ln here also. So by introducing the ln, we drop the exponent. So that will be 2x ln of e, of which we know that the ln of e is 1. So this is the ln of everything that you're given here, 5 plus the square root of 21 over 2. Or you're going to have this side, you drop the exponent again. So that will be 2x. The ln of e is equal to the ln of 5 minus the square root of 21 over 2. So we can simply divide by 2 because the ln of e is 1, remember? So we just divide by 2 here, divide by 2. The same thing, divide by 2 by 2. So that means we've got our x. So therefore, our x will be equal to what? All right. The ln of this over 2 is simply like there is a 1 here, 1 over this. So you can even write it this way, just for simplification. So you're going to just have it as 1 over 2, the ln of 5 plus the square root of 21 over 2, like this. Or you're going to have the same thing here, just like what we had, cancel these two. So x will be equal to, again, this is the same as 1 over 2. So you're just going to write as 1 over 2, the ln of 5 minus square root of 21, everything over 2. So that is in exact form as we are given before, in exact form. We do not want any decimal there. In exact form. All right, so this is it. That's how our questions might be given, as you need to be very, very, very careful in your simplification. Make sure that you do understand the concept that you are given there. All right, so that's it, guys. Let's see another part of our question. Let's see what we got here. Other part of our question. Again, on number 5, in exact form, you're supposed to find the values of x for which this inequality is given as, and giving the answer in exact form. That is 7 marks. Okay, let's check our inequality. So just like as we do understand the solving part of our inequalities, we are going to do the same thing, only that you're given this must be in exact form. So this is greater than 2x plus 1. We do not have any modulus there, guys. This was a simple question. Just expand your brackets. So expanding brackets, you're going to have x squared minus 6x plus 9. Remember your identities. Then after expanding the brackets, transpose this to the other side of our equation. So that will be minus 2x minus 1 is greater than 0. All right, so let's solve x squared minus 6 minus 2, that's minus 8x. 8 minus 1, that will be plus 8, is greater than 0. So we do understand that at this stage, we are supposed to have this as an equation, x squared minus 8x plus 8 is equal to 0, where you find the critical values of this equation that you relate according to the graph, because we can see this, we can even use the graphical. There is just a normal quadratic, guys. Remember your quadratic graph, having positive is like this. You can even relate from the graphical method. You can relate from the number line, whatever that you want. But we need critical values when we solve this as an equation. So just like the previous case, from our normal quadratic, x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. So x is equal to, that's the 1 here, b and c. So you're going to have minus 8 plus or minus the square root of b, which is negative 8 squared minus 4 times a, which is 1 times c, which is a positive 8. And this whole part is over 2 times 1. All right, so on this one, I want you to be very, very careful. Just use your calculator in the simplification. Depending on the calculator that you guys, advanced level, do not use DAL, that do DAL in A level. Use the one that simplifies also in exact form. You have a calculator also that corresponds to whatever level that you are at, so that also in your simplification you do not have challenges in your simplification. All right, this is what I'm trying to say. If you have got something like this, I want you to say, you do not struggle like now you have to start by simplifying what is inside of the bracket. Then after that, you are applying your mathematical knowledge. Like you are straining yourself with all that. If you have got something like this, you just put a fraction. All right, I'm not saying if you have that one is wrong, but just try by all means to have something that can help. So if this is 8 minus, that's a positive, plus the square root of, we're going to have a bracket there, which is negative 8 squared minus 4 times 1 times 8, everything over 2 times 1, which is just a 2. Guys, you see, this is the exact form they're saying. So if you have something like, you do not struggle, the answer is already there, automatic. So you say, okay, this is my value. But if you've got that one of yours, guys, most that you want to advance with from your O level, that DAL, you have to know your sets back to your O level again, You see now the part that I'm explaining. So please have a proper one, okay? So there we saw that this will be 4 plus or minus 2, the square root of 2, meaning to say the x is either 4 plus 2, because it's going to be plus or minus, definitely, guys, this plus or minus. So I used a plus, so the other one will be a minus. So you're going to have 4 plus 2, square root of 2, or our x is going to be 4 minus 2 square root of 2. So with these exact values that you are given, guys, you do not, like, you can see that, okay, this is a value, like there's a negative. This is smaller than this one. But we do not know, is it going to be a negative value? Is it? So just try also. This is your calculator. Yes, they said exact values. But on your calculator also, just try to simplify and see what is the decimal corresponding there. 6,8. So you can see on this one, it's corresponding to something like 6,8. Okay, let's see when it is a negative, what was going to be the decimal, so that we do know, like, where is it going to pass? Like, is it going to be the negative region or what? 1,7, something like that. This is 1,2, something, 1,1, like that. I'm not saying this is important, but just also do understand your values. What are they representing? So we are not going to have this as decimals, but we're going to use them as they are in exact form. We just see, okay, these are positive values, as we can see, but they are representing the solutions to our function. So if we were to use the graphical method, this is our x. So you're going to have our function. That's a positive. So you're going to have a smiley shape like this, something of this nature. So passing through the smaller value, that's this one with a negative, this one. So passing through 4 minus 2 square root of 2, and also passing through this one, 4 plus 2 square root of 2. So let's consider according to what we are given on our function. Remember, we need greater than 0, above, greater than 0. So it's above the x-axis. Y is equal to 0 in the x-axis. So here we are talking about y. This is y here that you're talking about. It's x, yes. What you can see is written in terms of, but that is y. Y is equal to this. So y is related from this to say y is supposed to be greater than. So where are we having this y, this one? This is our y. The function is y, this one. Where are we having it? Above 0, greater than. That is on top. So this side and this side, this is the side that you are representing. So therefore, our x is going to be less than on this other side. So that is less than 4 minus 2 square root of 2. Or our x is going to be greater than this other solution that we are given, which is 4 plus 4 square root of 2 plus 2 square root of 2, sorry, like this. So that is in exact form, no decimal, no decimal. So that is how we could have solved this inequality. You had to consider your normal simplification of a quadratic, then solve, finding the critical values. Then after that, you compare with any method that you want, that you understand. Because guys, we've got different methods that you use in your simplification. That one is up to you, which method that you use to determine your final answer at the end. All right, question number 6, a chord XY, that's a chord, subtends an angle of 2 theta radians at the center of the circle. Radius R and center, or given that, okay, let's just start with this part before we get into that statement that we are given. There is a chord, and as we do understand that this is simply taken from a sector. So you just have something like this. So this is a chord creating a sector. We're supposed to give us a complete circle, as we do understand. We're supposed to have a complete circle there, but just we are focusing with the chord. So you're given that it's a chord at center O, having radius R, and the angle is given as 2 theta. That is what you're given. A chord, the angle that it subtends is 2 theta, its radius R. Then let's get to the statements now that you're given. Given that the area of the minor segment is 1/6 of the area of the major segment, show that, all right, the area of the minor segment is 1/6 of the major segment. Area minus segment, area minus segment is equal to 1/6 area major segment. That is what you're given there. So we are asked now from this whole situation that we are given, this whole statement, we are supposed to prove that the sine of 2 theta is equal to 2/7 into 7 theta minus pi. Sine of 2 theta is equal to 7 theta, 2/7 into 7 theta minus pi for 7 marks. Prove that. This is only what we have. Okay, let's figure out. We do understand that this is the minor segment of our circle. This, from the presentation, this will be the minor segment. So given an angle of 2 theta that we are given that subtends this angle at the sector, then we are given that the minor segment is 1/6 of the major. So the remaining part here is our major segment, this one. That is the remaining part, is the major segment. So I want us to see one thing here. The minor segment and the major segment together gives us the complete circle. Gives us the complete circle. So let's say I wanted to calculate this, direct the area of the minor segment. It was going to be like this. The area of minor segment, besides of being given this statement of a circle concept. The area of a minor, this one, besides being of that major segment, the area of the minor segment is supposed to be from this sector. Okay, it's supposed to be from the sector. Let me separate the part that I'm explaining here. It's supposed to be from the sector, this one. A sector affecting this segment that I'm shading here. It's the whole of this. This is the sector affecting this segment. So it's the area of the whole sector that you are given minus the area of this triangle. What makes this sector is the segment and the triangle. The segment and the triangle. So given that this is, we are supposed to have it from that concept, that this is radius and there is an angle of 2 theta. So we do understand that the area, so it's going to be area of sector, area sector minus area triangle. And the area of a sector is given as half r squared theta from the normal formula, half r squared theta. Our theta is the angle, and our angle is not theta but 2 theta. So we're going to multiply to 2 theta. Minus area of the triangle. Remember our area of a triangle from half AB sine of C or sine of theta, where A and B are the sides creating angle. So it's going to be half AR times R, which is R squared, the sine of theta, our angle, which is 2 theta in that case. This is supposed to be the exact formula of the area of the minor segment from a sector that we are given. But no, they are not relating to that. This is the exact formula, the exact answer for our minor segment. But they are relating the same area that we just calculated, this same area that we calculated. They are giving us in terms of a statement that it is 1/6 of the major segment. So let's calculate the same area of this minor segment in terms of this statement. So it follows that the area of the minor segment is going to be 1/6 of what? The major segment. So now ask yourself, how are you going to calculate the area of this major segment, this one, the area of this major segment? Remember what I said, it is composed of 2 things. The circle is composed of 2 things, the major and the minor. So if we take the whole circle like this, we know its area. So the area of the major segment that we are talking about in this case, this one, this major segment, this one, it is simply the whole circle. So you're going to talk of the circle considered. So you have the circle considered, it's there. Out of the complete circle that you are given, we are going to subtract the minor segment. Guys, remember that these two, they make up a circle. Minor segment plus the major segment is equal to the circle. So as we want the part of the major segment, so it's going to be circle minus minor segment. So what is the formula now? That is what we want here, because we need circle, because this is the major segment. 1/6 of the major segment. So what is the area of a circle? Pi r squared. Minus, what is the area of the minor segment? That is the question. We have this expression, which is exactly the formula that we are supposed to have for the minor segment. Isn't it? That is exactly this one that we have. So we are going to take our minor, this is the area, guys, of the minor segment, but it's supposed to be removed from the circle so that we obtain the major segment. So we subtract our minor segment from the circle. That is, we are obtaining what? The area of the major segment, so that 1/6 of the area of the major segment gives us the area of the minor segment. So it's like a repetition. We take that, we take it again. They wanted you to have confusion there. So it was going to be half r squared times 2 theta minus, remember, our minor segment that we calculated, half r squared sine 2 theta, like this. So these are two things to be considered. So let's simplify this area of the minor segment that we have this side and simplify this. It's up to you. Or since these two are just equal, just solve them direct. It's up to you again. But what we do understand is that this area, the normal area of a minor segment, we calculated the normal way. But this one, guys, we calculated it from the statement given, but representing the same thing. So are we going to have different answers? No. If we calculate this having the numerical value, if the answer is 2, this also is going to be 2. So if it is like that, we can take this as an advantage, say they are equal. So let's equate them, because there is no way that the area is different. The area that we have of that minor segment will be equal to the area of the minor segment that we are going to have also calculated in terms of what? Calculated in terms of the statement that you are given. So we take the area of the minor segment, the normal way, the normal one that we are used to, this one. This is the one that we take it as it is. That is half r squared 2 theta minus half r squared times sine 2 theta. We equate it now to that one that we are given this side. This one that we are given here. All right? So we're going to equate. So here we can even expand the 1/6 into this. So it's 1/6 into this. So that will be 1/6. Sorry for that. So this will be 1/6 pi r squared. All right, the 1/6 here, take note there's a bracket. So it's going to multiply this then with a negative also. So it's 1/6 times this with a negative that we are seeing here, guys. All right, or let me just put it this way. Minus 1/6 times 1/2 r squared 2 theta, so that you do not have a confusion here. The 1/6 also multiplies here, but take note the minus must multiply, so it's minus, and the 1/6. So it's going to be minus 1/6 times the minus 1/2 r squared sine 2 theta, like this. So this one is already having a negative, but the 1/6 must carry a negative also to enter that bracket. All right. So this is it. These two are equal. So from these two, we are supposed to finalize that statement that we are given above. All right, let's check. There is r squared, which is the same here, half r squared actually, that is the same. Okay. Before there, we're not having a half on this circle. So let's just consider the r squared only, so that we do not have confusion. Let's start with r squared. R squared is the same, cancel. R squared is the same. 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 All right. Then also here we can cancel half of 2. That will cancel. So we're gonna remain with the direct theta here because this cancels. So theta, there we're gonna have minus 1/2 the sine of 2 theta. Don't be tempted to cancel this. This does not exist, all right? Then on this part, we're gonna have 1/6 pi. And here we're gonna also cancel the 1/2 and the 2 cancels. So you remain with minus 1/6 theta. All right, there we're gonna multiply negative times negative. That will be plus, that's positive 1/12 sine. Where am I getting sine theta, guys? Like, where am I getting sine theta? This was sine 2 theta. This is 2 theta here. So it's gonna be sine 2 theta. All right, so this is what we have. The answer was written in terms of sine 2 theta. So we just have to make sine 2 theta the subject. So can we make sine 2 theta the subject? That is the question, because that answer there, sine 2 theta, is the subject. So make sine 2 theta the subject. That is what we can see, because we have got the answer. So you also have to relate from the answer. All right, so let's take the part of sine 2 theta to one side of the equation. This will be to be a negative there. So it's negative half sine 2 theta negative 1/12 sine 2 theta, which is equal to, on the right-hand side, we are going to remain, there is a 1/6 pi there, minus 1/6 theta. We take the theta that side, it will be a minus theta. It was a positive. So this theta to the other side of the equation becomes a negative. So as you can see, we have got the theta and the theta considered sine 2 theta. So you can even consider these are like terms. So you simply combine the numbers, minus 1/2 minus 1/12. That is minus 7/12. The sine of 2 theta, which is equal to, we've got like terms to consider this side. Also, we've got theta and theta. So this is minus 1/6 minus 1. So minus 1/6 minus 1 is minus 7/6 theta. There is a theta, remember? So all we just need is to make sine 2 theta the subject here. So what is affecting sine 2 theta is the minus 7/12. So simply divide by that. By minus 7/12, divide by minus 7/12, divide by minus 7/12. So this simply cancels. We remain with a sine of 2 theta equal to. So if you divide these two numbers here, you're going to obtain a 2. So that is going to be 2/7, actually. That will be, all right, this one is going to be a negative 2/7, negative 2/7, negative 2/7 pi, and this one will give us a positive 2. That will be 2 theta. All right, so you can even just start to, we just write with a positive, just start with a positive there. So it's going to be 2 theta minus 2/7 pi. All right, this is exactly what we have. Now, let's see. There is something that they did. So you have to check also, guys. You have simplified, but also verify. On your final answer, what happened? They just factored out 2/7 there. So there's nothing that they did. They just factored out. So you might be wondering, my answer is not exactly what they are having. Yes. Consider also the last statement that you, so there they just factored out the 2/7. So let's factor out the 2/7 and see. So if factor out 2/7, it means here you're going to divide by 2/7. Here you're going to divide by 2/7. So by dividing by 2 over 7, this will give us a 7. So that's positive 7 theta. By dividing by 2 over 7, this will give us a minus pi. So you're going to remain with a minus pi. All right, so that's it, guys. As we can see, this is what you're supposed to show from the information that you were given. So I don't know. I just do not know if we are together here. Just make sure you do revise these typical questions also as an individual, because they do repeat these statements. If you check this question, revise other question papers, you see it was actually from another question, just change here or there. So do work with as many questions also as you can that can actually help in your revisions. This is important that you do work with your question papers. The more question papers you do, you'll see that it's just a repetition throughout. So if we take a closer look, number 7, that was the application of our binomial. That is, you are asked to expand this raised to the exponent of a fraction. That is best to us to apply the binomial in up to, so take note, up to and including the term in x squared. Simplifying coefficients, you must simplify the coefficients. All right, so let's just see how we're supposed to attempt our binomial expansion. That is, consider also the binomial expansion from our mathematics N4. I explained this typical topic so that at least you can understand the basics there. So remember, we are supposed to just apply like the derivative concept, guys, okay? So this is it. You raise, the first one will be raised to the exponent of that x that you're given of a half. So that is 1 raised to the exponent of a half, okay? In actual sense, you were supposed to have this as just like 1 plus minus 2x so that you properly see that what you are working with there is the minus 2x. So there's nothing to worry there. So remember I said the first term, you take that minus 2x as it is, but it will be raised to the exponent of a 0, meaning to say there is no effect there. All right, there's no effect. Plus, this is what you do. The first term, you just consider its derivative, just like you're differentiating. Remember your derivative concept. You drop the exponent, you subtract 1 on the x. That's the concept. You drop the exponent. If you drop the exponent, that will be 1 over 2. You subtract 1 on the exponent. So that will be what? Half minus 1, that's minus a half. That's it. So on this part, that the first part that you start with here, raised to a certain x, the one that is being raised to the exponent of that bracket that you're given, is the one that you focus with. Just find its derivative throughout up to the last term. This other part will be increasing in terms of its exponent. There we started with a 0, so it's going to increase. So it will be minus 2x this time to the exponent of a 1. Now we can use the 1 factorial. Plus, again, you do the same thing. You find the derivative of this. Already there is a half which is there, so you're going to start with that. Then you find the derivative. How do you find the derivative? Remember, you drop the exponent. So you're going to drop the exponent minus half. We subtract 1. So that is going to be 1 to the exponent. If we subtract 1, that will be minus 3 over 2. The part of 2x is increasing. All right, remember that. The part of 2x is there is just increasing. Minus 2x to the exponent of 2 over 2 factorial. That's it. So that is up to, as you can see, x raised to the power of 2 here is x squared. So we are done. We're not going to do simplify and so on. If you wanted to, it's going to be, you drop the exponent again. You do like that, you subtract 1 and so on. This one increasing and so on and so on and so on. So make sure, like I said, you watch the N4 binomial theorem. I explained about that part. All right, so this here is simply a 1. So we simply have 1 to the exponent of a half, which is simply 1. All right, then we simplify again. 1 raised to any exponent, guys, it's a 1. So there, do not worry, it's just a 1 that we are having here. It's just a 1, this one, okay? So simplify this We can even use your calculator. Right, so this is 8 here, so you're just gonna have 1 over 2. So that's 1 over 2 times minus 2 raised to the power of 1. So minus 2, guys, raised to the power of 1 is simply the minus 2 that we know. So this will be minus 1 divided to 1 factorial. Guys, 1 factorial is just 1. All right. This 1 factorial, this one is just 1. So it will give us simply a minus 1. All right. So in terms of the numbers, we are going to obtain minus 1 multiplied to what? X raised to the power of 1. So x raised to the power of 1, it's x. So this is simply minus x. So you do the same thing. Where there's a 1 here, 1 raised to any power, guys, is simply a 1. So do not worry about that. So this time, we will need our 2 factorial. Let's just have a fraction. That will be 1 over 2 times minus 1 over 2. That is minus 1 over 2. Then you multiply to this. This is minus 2 squared. Take note, minus 2 squared. So you open a bracket there. Sorry, that is just times minus 2 squared. So open a bracket, minus 2. You square it over what? 2 factorial. So this is over 2 factorial. So that was going to give us a negative half. So we are obtaining negative half in this case. But it's being affected by the x. X raised to the exponent of what? Of 2. So that will be x squared, just like that. So that is, they said you must simplify coefficients. So this was going to be like this in a simplest form. All right, so that was it, guys. Then from there, state the values of x for which the expression or the expansion is valid. So whenever you are given this format, guys, when the expansion is valid, you are given something of this nature, 1 plus or minus ax raised to a certain exponent here. For this to be valid, you concentrate with ax. Ax, the modulus of ax there is supposed to be less than 1. So in this case, the part of ax we consider the minus 2x. So in this case, it means the modulus of minus 2x is supposed to be less than a 1. So we can solve that, find the values of x. Remember the modulus, guys, simply talking of positive or negative. So we've got positive minus 2x less than 1 or a minus of minus 2x. A minus of minus 2x less than 1. So you can solve. That's minus 2x is less than 1, divide by minus 2. By minus 2. So the moment you divide by a negative, remember, the inequality sign reverses. So that's greater than minus half. Or you can have this minus minus, that's a plus. So 2x is less than 1, divide by 2. So x is less than a half. So these are the solutions. X is supposed to be greater than a half, or x is supposed to be less than a half for this to be valid. All right. Okay, sorry for that, guys. I did not want to remove this. Okay, sorry for that. So number, the C part, by putting x is equal to 1 over 9 in the expansion, in this expansion that we had in part A, whatever that we had on part A, show that the square root of 7 is going to approximate to 143 over 54. By putting x is equal to 1 over 9. I want you to see what's going to happen here. So this is, you study this from what you are given. Remember, this is our expansion that we had, 1 minus 2x to the power of half. So I want you to see this. 1 minus 2x to the power of a half. Guys, to the power of a half simply means the square root. So it's the square root of 1 minus 2x, because there, they want you to determine the square root of 7. So write it in the way that you understand. This is to the power of a half, simply means the square root. But I want you to see, if you substitute x, which is 1 over 9, if you're to substitute x, which is 1 over 9, it was going to be like this. The square root of 1 minus 2 times x, which is 1 over 9. You were going to obtain 7 over 9, the square root of 7 over 9 like this. This is what you're going to have. Like, if you simplify this, it was going to give you 7 over 9. So as we can see from this, we cannot determine the square root of 7. We do not know the square root of 7. So you're just going to write a square root of 7 over The square root of 9, we know it. So the square root of 9 is equal to what? Is equal to 3. Guys, we were substituting x, which is 1 over 9, into this expansion. And this expansion, we know that it is equal to this part that we are seeing here. This whole expansion that we are seeing there, it is the same, because this is the expanded part. So the question is, how are we going to obtain the square root of 9? The square root of 7. We are going to take this as it is. This is what we got. Guys, when we substitute from the 1 minus 2x to the power of a half, which is the square root of this, we got the square root of 7 over 3. This square root of 7 over 3, it's not by mistake. It was taken from the same 1 minus 2x. And this same 1 minus 2x that we are seeing raised to the power of a half, it is equal to this expansion that we are seeing. So from this, we are obtaining the square root of 7 over 3, not the square root of 7 direct. There is over 3 there. So when you substitute both the 1 over 9, it was when you from this square root, and it is the same as this expression that you have. So as you substitute, you're going to substitute 1 over 9 into your expression in terms of what? In place of x, you substitute 1 over 9. But you are simplifying the square root of 7 over, as we saw here, when you substituted into the square root, it gave us the square root of 7 over 3. So the question is, what is going to be the square root of 7? So as you can see, we can remove the 3 here by multiplying it both sides. Multiply by 3. So that means we are going to obtain an approximate of the square root of 7 from this simplification, because we have removed this. So that is going to be 3. Simplify this whole bracket. You are going to obtain 143 over 162. Guys, this is the purpose of your calculator. Use your calculators. Multiply this. That is the square root of 7 is going to approximate to 143 over 54. So that's it. You express from what you are given. The statement that you're given is the one that you're simply working with. All right, so that was our question number 7. Question number 8, you are given a line. The equation of a line L is y plus 3x, which is equal to 9. And from this equation that we have, find the equation of line M. So there is a line M. There's a line M to be considered there, okay, from this. But this line M, that is perpendicular to line L. All right, there's something considered from our line L. Remember our line L, y plus 3x minus 9 is equal to 0. If they are perpendicular, we have to consider the gradient. And by writing this equation in the form of y is equal to mx plus c, we can see the gradient transpose. 3 will be minus 3x, minus 9 will be positive 9. So this gives us the gradient. Remember, m is the gradient. So from line L, the gradient of line L is minus 3. So if we are told that these two lines, they are perpendicular, it means we are going to consider that for perpendicular lines, the product of the gradient of the first line to that of the second line must be equal to minus 1. So the gradient of this line M, we do not know it, but we know the gradient of this other line L, which is minus 3. The product is supposed to give us a minus 1. So that means by dividing by minus 3, you are obtaining the gradient of the line that you are supposed to calculate its equation. So we have got the gradient. So what is missing is the point. We have got the point again. Passes through the point A, which is 1,6 there. So you have got a point. You are given a gradient and you also have a point 1,6. So write the equation and you are given also the format. Ax plus by plus c is equal to 0. That's the format that you are given to use. So in this format, I would favor just to use this format of an equation. Y minus y1 is equal to m into x minus x1. Yes, you can even use the gradient concept of y is equal to mx plus c, you substitute gradient, which is fine. Still, you can even change thereafter. So this one is just y minus y1, which is the point. Remember, this is our x and this is our y from the point that you're given. So y minus 6 is equal to m, the gradient of line M, which is 1 over 3. So this is going to be 1 over 3 into x minus x1, that is the value of x that we're given, which is 1. All right, expand the brackets and so on. Y minus 6 is equal to 1 over 3 times x. That's 1 over 3. 1 over 3 times minus 1. Minus 1 over 3. You can even clear the fractions. Just multiply by 3 here, by 3 here, by 3 here, by 3 here. So that means we've got 3y minus 18 is equal to x minus 1. Then let's take the terms. As you can see, we're going to have this format: ax plus by plus c is equal to 0. So we can even avoid having x as our first term and being negative. So you can take these terms this side. So it means 0 is equal to x already on the right side. The 3y will be minus 3y. The minus 18 will be plus 18. So we're going to have a plus 17 in this case. All right. So that will be plus 17. So that is our equation, guys, as we can see. So we can just have, therefore, x minus 3y plus 17 is equal to 0. There we are just avoiding to start with x as a negative. Yes, you can transpose it as a negative there. Then you divide by minus 1. It's up to you. But that is our equation in the format that we are given there. Then another part, it was the equation of the line parallel to L. The same L that we had here, which has got a gradient of 3. This time they are parallel. So remember the concept of lines which are parallel. If two lines are parallel, their gradients must be equal. The gradient of the first line must be equal to the gradient of the second line. So it means line L, we know its gradient is 3. So it means the gradient of this line will be equal to minus 3. We have that, minus 3. But it passes through the point B. We have got the point where it passes, which is 5, 6. And you need the equation. So guys, we can simply use the same concept depending with the way that you want to have it. You want it to have in the y is equal to mx plus c, whatever way that you want. So using the same previous format here, we're going to have this as our x1, y1. So that is y minus y1, which is 6, is equal to m. That's minus 3 into x minus x1, which is 5. Just like that. So y minus 6 is equal to minus 3 times x. That's minus 3x minus 3 times 5. That's plus 15. If you want, you can even have it in this format that you had before. It's up to you. X is negative. We can take it this side, becomes a positive. So that will be 3x plus y. Then we transpose the 15 this side. It becomes a negative 15. So minus 6 minus 15, that's minus 21, is equal to 0. So that will be the equation of that line parallel to L. So if you want, you can even have it in the form of y is equal to mx plus c. Guys, it's up to you, where you can transpose y is equal to minus 3x plus 21. That is up to you. Okay? We are not told the format there. This time we need to find the perpendicular distance from the point B, this point B, 5, 6, to the line M. Remember, the line M is the first one that we calculated on A. This is our line M. Remember, this one is our line M. So they're saying we need a perpendicular distance from the point B that we are given to a certain line, but it must be perpendicular from the point B that we are given. Remember our point B, that's 5, 6. To the line M, whose equation is given as x minus 3y plus 17 is equal to 0. So actually writing in this format, they also wanted you to, guys, not to have a confusion there, because remember the distance, we can even use the distance formula, provided that this is in the form of ax plus by plus c is equal to 0. And this point is x1, y1 like this. We can have our perpendicular distance from this point here to this, which is the perpendicular distance, as the modulus of ax1 plus by1 plus c, everything over the square root of x squared plus y squared, which is taken from a and b. So let's just use a and b there, a squared plus b squared, which are the values, the coefficients of x and y from our equation, okay? So there we simply have to substitute. So therefore, that is the modulus of A, the value of A, that is the coefficient of X here. That is 1 times the X1, which is our X at the point. So that is 1 times 5 plus B, the coefficient of Y, which is minus 3 times Y1, which is the point that you're given, the value of Y at the point, plus C, which is the coefficient. When this equation is written in, take note the format, is equal to 0 is equal to, this is the format. So if the equation was of Y is equal to mx plus C, you have to rewrite in this format. So that is our modulus over, so you're going to have over the square root of A squared plus B squared, which is A, remember, the coefficient of X. So that's 1 squared plus B squared, which is minus 3 squared. So that's it. We are going to obtain the perpendicular distance between this. We can use this concept. So guys, I want you to simplify. Remember the modulus, even if you get a negative, you write it as a positive there. So that was going to give us a 4 over the whole of this part was going to give us the square root of 10. We can even rationalize, but if you have those calculators, guys, the calculator will give you the answer direct to square root of 10 over 5. This is it. The rationalizing, guys, is now up to you. Multiply by square root of 10 over square root of 10. You obtain 4 square root of 10 over 10. Now you start to reduce by 2. What's the purpose of the calculator now? If our calculators have that exact format, there's no need for us to go back to our SEDS format. The calculator can give you the exact answer there. You can have the exact answer from your calculator. So these are the typical questions to consider in our revisions. So that was the first part of our revision. Like I said, we are going to work with this part up to the end. Just make sure that you stay tuned. Do yourself a favor to subscribe to this channel so that you won't miss any of the classes that we shall have. And you also prepare for your engineering as you are advancing with your educational life. We also have engineering on this platform, so that can be an advantage to you in terms of your revisions. And as a future case, we are also supposed to have all subjects that can cater for our advanced. After this, we advance later on, we need those. So that is the case, guys. So let's do revise as much question papers as we can. And like I said, you can contact with your question papers so that when I've got time, I'm going to work on that part so that we can revise for these exams that are ahead of time. But for now, that's it. Till we meet again.